value. Here is how you find average value. Okay, basically, if you want to know the average value of a function, you could take its antiderivative from a to b and divide by b minus a. Okay, to find the average value of a function, you can take its antiderivative from a to b, or its integral from a to b, and then divide by b minus a. Yes.
Is it just me, or does the setup to the right look a little familiar?
It does.
So we did before this divided by the integral, or like b minus a.
Right. So it's basically what we've been practicing, except now we're going to divide by the length of our interval.
X over changing what?
Except it's the change in antiderivative.
So that's what we're just doing, is now we're dividing by.
Uh-huh.
We couldn't do that with the other one.
We had to learn that first.
Wait,
I wanted you to practice before we get through this. Okay?
so, just a little piece, basically, it's like especially when we're doing over the interval length.
Mm-hmm. Okay. Are we all on the same page now?
Yo, man, come on.
Okay. So we're going to find the average value from 1 to 3 of this guy. There is a proof of the average value in your book if you're interested in why it's the formula that it is. We'll also use the average value for some AP problems that we'll look at next week. Okay. All right. So to find the average value, we will want to take the integral from 1 to 3 of our function.
So is this just the same thing just
Divide by.
yeah.
Okay. So now we're going to multiply by 1 over.
We need to, let's say, divide by.
You can either write a big divide by 2 or say multiply by 1/2. How am I getting that 2?
Because 3 minus 1 of the integral.
Because 3 minus 1 is 2. Our interval is from 1 to 3. Okay. So I'm just going to go ahead and write it as 3 minus 1. Okay. Okay. So it's really 1/2. And if you want to do division instead of multiplying by a fraction, it doesn't bother me. Okay. So now we have 1/2 times, what is the antiderivative of 3x squared?
X squared or x cubed.
Minus x squared from 1 to 3. What I'm going to do is I'm going to wait for the 1/2 until later. Okay? So we have, plug in 3, we have 27 minus 9. Minus, plug in 1. 1 minus 1. What is your average value? You want to visualize it?
Wait.
What? 18 times a half?
Oh. Okay, good. I think I got it.
What was our function?
3x squared minus 2.
So here's x equals 1. Oh, we're going to have to... Okay, hold on. So here's x is 1, and here is x is 3. Okay, so did you see that? X is 1 to x is 3. Average value of 9.
That's about right.
Yeah.
What do you figure when 9 is like this? 9?
The average value.
No, it doesn't.
Average what?
So the average value. Like if I take all those points and average them up, basically.
Look how high up we go, and we go past 30.
Right.
Isn't that 20?
We're talking about an interval.
Yeah, we're talking about in the intervals of 1 to 3. It kind
So
of looks
the
like
average
it'd be
y
like
value is
1.5.
9, is what that's saying.
Yeah.
Oh, right.
It's because it gets steeper faster
Oh, I see.
the higher you go.
I see.
Right? Okay. Calculators. Well, there are times where you will be allowed to integrate with your calculator. There will not be very many, but I would like to teach you the skill. That way you can check your answers and practice the skill. Okay? Having an issue with my TI-84. Okay, so how do we find derivatives on our calculator? Math.
And derivative.
Okay, math 8 is our derivative command. Do we remember that?
Plug in our formula, comma x, comma our value for x.
Yes. Okay, so we can find a definite integral in our calculator. Go to math,
So that's right.
and instead of 8, it is 9. Now those of you with fancy 84s, it just brings up a nice integral and you can just type your limits of integration and blah, 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 blah. If you have a calculator like this, what you're going to have to do is plug in the function. So 3x squared, was it minus 2x? Okay. And then you're going to have to tell it, comma, I want you to do this with respect to x, comma, from 1, comma, to 3.
But then you have to divide by 2.
And then for our average value, we divided by 2. Yes.
What was the button?
Math 9. Math 8 and Math 9 will be your friends.
But we're gonna use them at all in this class. But not everything.
They will become more your friends as we get into our next 2 units.
Physics is helpful.
Yes. Ready? Yes.
There's one other something in my GI encouragement.
I think you're doing one with that.
Can we start working on the other?
Hold on.
Oh, well. I don't have your calculator.
They're going into
Okay, so I'm going to give you one to practice with your calculators. Yes, Kristen.
Interval.
What? Okay, you're taking the derivative. You math 9.
30.
Oh,
And,
90.
Okay, so with your calculators, I want you to find the average value of x cubed from 2 to 4. Keep it to yourself for at least a minute.
Can we use this on the test?
There will be a calculator portion of your test. There will also be a non-calculator portion of your test. Please stand up if you have an answer.
Can I just raise the calculator?
Stand up.
Oh, I didn't.
Well, I'll get there. All I want you to do is find the average value. I'll get to the other part of this. What kind of this do you have the All right, what's our average value? FC? 30? Okay, so our average value is 30. I want to know where that occurs. What x value?
at about 3.22.
How do we figure that out?
Plug in that for fx.
And then solve for it, and then cube root it.
So the cube root of 30 is where that happens. So when x is cube root of 30, y is 30, and that is where our average value occurs. Okay. So what you will add on to your assignment is 51 to 55 odd. 63 you can use your calculator for. Okay. So what I'd like everybody to do is 51 from the same page. Everybody's going to do 51, and when you have it done, you're going to stand up, touch two walls that are non-adjacent, and then sit back down.
Just 51?
Just 51. Check your answer. So you get it done, check your answer. All right. Let's remind ourselves how to do U substitution. When do we do U substitution?
Make u and s1 x squared plus 1.
When you have a function times.
Well, the biggest thing you should look for is a function inside of a function. Like here, x squared plus 1 is inside of the 50th power. Okay? So Zach suggested to let u equal, what, Zach? Sure, you could, if you're crazy. Okay? Zach's not listening. Zach suggested let u equal x squared plus 1, which means du is 2x dx. Here is 2x dx. So we can write this as the integral of u to the 50th du. So we have 1 over 51 u to the 51st plus c. And then we go back and we substitute u back in. We all remember that?
Yes.
It was a great moments in January, okay? Now what we're going to do is we're going to have a definite integral with substitution. Oh wow, look at that. Looks awfully familiar, doesn't it? Okay, so the integral from 1 to 3 of x squared plus 1 to the 5th times 2x dx. Okay, so you need to remember that when we have the composition, that is your key to maybe we should try u substitution. So u would be what? X squared plus 1. Du is 2x dx. Here is 2x dx. So we replace it with du. And then this becomes u to the 5th. Now I'm going to show you 2 different ways we can do this problem. Okay? Since this is in terms of u, our limits of integration are not 1 to 3. So one thing we could do is we can say, all right, well I know that this is 1/6 u to the 6th for the antiderivative. So then we can go back to our problem and say, all right, this is 1/6 x squared plus 1 to the 6th, and we want to evaluate that from 1 to 3. So I did the antiderivative with the u's and then changed them back to x's so we could evaluate our hold on. Okay, I want to finish this. So we have 1/6 times 10 to the 6th minus 1/6 times 2 to the 6th. So I plugged in 3 to x squared plus 1 and it gave me 10. Is that okay to do in our head?
Yeah.
Okay. It's and then I plugged a 1 in 1 squared plus 1. Okay.
Very large number.
Yep. Anyone want to find it for me?
Can we just leave it in representation?
It's really not that bad of a number.
How about that?
The thing didn't beep, so I just. So I thought it was a pair, so I stopped running. So what did you think?
Okay, so I plugged 3 in to get 3 squared plus 1, and I just wrote it as 10 to the 6. And I plugged 1, I just wrote it as 2. Okay, maybe I shouldn't have done that. What did you get, Carly? Just like this is.
166,656.
I know, so I feel like.
Is that what you got on your calculator? Guys, can we focus? We only have like 10 minutes left.
Why couldn't we just, if we're able to use a calculator, why couldn't we punch in our calculator?
Because you can.
Okay, so this probably would not be a problem. I would say don't use your calculator on.
But if you could use our calculator, then we could just punch it in the math numbers.
Right.
I think that's wrong.
So it's just trust factor.
Well, what I'm going to ask is that for your homework, you do them by hand and check them with your calculator, because you are going to have to do both ways. Okay, doing it without your calculator is probably more important. Okay, because I mean the calculator is easy to do. Okay. Now, how else could we go about doing this? Okay, so this is the exact same problem. Okay, way number 2. And I do not have a preference. Let's recap what we did over here. We used u's, we changed them to x's, we evaluated. Here, we are going to once again let u equal x squared plus 1, which means du is 2x dx. And so this becomes the integral of u to the 5th du. Now, last time we just integrated from here, but what we can do is we can change our limits of integration to be in terms of u. Okay, so I'm going to go here. What our lower limit is x is 1. So if x is 1, what we can do is we can say u equals 1 squared plus 1, which is 2. So our lower limit of integration becomes 2. Then our upper limit of integration is 3. So if I plug that in to u equals x squared plus 1, u is 10. So now I've changed my limits of integration to be u's, and we don't have to worry about the x's anymore. All we have to do is say 1/6 u to the 6th and evaluate that from 2 to 10. Because once again, we get 1/6, 10 to the 6th, minus 1/6, 2 to the 6th. That's kind of why I wanted to write it like that on the other side. Okay, so I do not care how you do it, whether you change your limits of integration or you change back to x. Either way is fine. Do another one.
Oh.
Okay. So most of you are going to college next year, and most of you are going to be taking a math class in college. More than likely, your math class is going to meet for an hour and a half at a time. Okay. So what we've done today, that's going to be like. I just want you to think about that. All right. Is this a substitution problem?
Yeah.
Brady, what would we let u be equal to?
4x cubed plus 1.
Great. Which means du is 12x squared dx. Oh, shoot, I only have x squared dx.
Let's change it.
So 112 du is what we substitute in for x squared dx. Okay? So this integral is now the integral. I'm going to put 112 du. Oh, that's a lot of space for just u to the 4th. Okay. Now, how many of you liked it when we changed the limits of integration? How many of you liked it when we integrated and went back to x? Okay, fabulous. That was like a 3-to-1 vote in a class of 15.
I don't know what
So I'm going to go ahead and just show you again how to change the limits of integration. Okay, in case that's the method that you want. If you want to go ahead without me and just do the antiderivative and go back to x's, then you can.
You're gonna require one or the other on the test.
No, I will not. So if x is 1, what would that make u? 5. If x is 3, what is u? 109?
Good job, guys.
Okay. Ooh, so we have 1/12 times antiderivative of u to the 4th. Evaluated from 5 to 109. So really what we have is 1/60th. Can't write it.
160, 109 to the 5th.
So we have 1/60th, 109 to the 5th, minus 1/60th times 5 to the 5th. Okay? On a non-calculator type problem, you would leave your answer like this. Right?
How would you want?
I bet that this ends in 7.
It doesn't mean so.
Okay, so this is the addition to your homework. Nope, no, it's not.
Oh, no.
I forgot to update this. Page 302, 55 to 62.
Can you go back to the previous one,
Real quick.
Actually, that's the one we can And we can just leave it like that. Yeah.
So we have to divide all of that. Oh, it's not having.
Will we have tomorrow?
Tomorrow we are going to review
FCC.
fundamental theorem of calculus.
So we don't have to do
We're
this.
saying.
Okay, so it's really more of a review day tomorrow. I'm really not sure why it says work day. Because we need to go back and work on Riemann sums a little bit more.
So do this as homework.
Yeah, so this is your homework. So, some of you have gotten a majority of page 288 completed. So you'll just have to touch up the last few problems, and then you have these problems to work on. Okay? Check your answers in the back of the book. On the even problems, how can you check your answers? With a calculator, but I want to make sure that you're doing them by hand still. Okay, there's about 4 minutes left in class, so that's probably enough time for at least one problem before you pack up.
Do we not have announcements?
We have announcements.
You know, on